Today's lesson number 22, we are going to talk about imaginary numbers and complex numbers. So what is the square root of -9? If we put it in our calculator, we will see that we get, where is it, second? Square root -9, a non-real answer. So in the past, you would have answered no real solution. And that is true. But now we know how to better answer this question because we're going to learn about the imaginary number. Sorry, that's supposed to be an I. The imaginary number of I, which is equal to the square root of -1. Okay, so if I take the square root of 9, or -9, and I divide it into -1 times 9, I now know that the square root of -1 is represented by I, and then the square root of 9 we know is 3. So to simplify that, I would get 3i. We also need to explore what I squared might be. So if I take I and I square it, that's the same as the square root of -1 squared. So we know that squaring the square root are inverses of each other, and they make each other go away, which leaves us with -1. So two very important terms that we are going to need to remember today are that I equals the square root of -1, and I squared equals -1. Okay. So here are some examples of using the I in our answers. So if we have this, we have the square root. I can split it up into -1 times 121 because I know that 121 is the perfect square of 11. And then that square root of -1 is going to give me I. So here is my solution for that one. Here, 28 is not a perfect square. Let's see. So we have 1 times 28, and actually 4 times 7 is it. So 4 is a perfect square. So I'm going to divide this into -1 times 4 times 7. And the square root of -1 we now know is I. The square root of 4 is 2. And then the square root of 7, since 7 is prime, we leave that under the radical. Now for multiplication, or any kind of operation with our I, imaginary numbers, we a lot of times treat it like a variable. So here if I have 5 times 2i, 5 times 2 is 10, so that's 10i, and there's nothing else I can do with that one. Here I have -3 times 2, which is -6, and then I have I times I, which is I squared. And if this was a regular variable like x, I would be finished. But because I know that I squared is equal to -1, I have to keep going. So I have -6 now times that -1. And -6 times -1 is a +6. So that's my answer when I simplify that. Okay. So next we have complex numbers. So a complex number is a combination of a real number and an imaginary number. And we write it in the form of a plus bi. So this actually is one number, even though it looks like two terms added together. So the a is the real part, and the bi should, hopefully that's obvious that that is the imaginary part because of the I. And when you perform operations, as in add, subtract, multiply, divide, you use combining like terms just like you would with regular variables. So here we are adding two complex numbers, and I'm looking for, like I said, we'll call them like terms. So here I have a constant term and a constant term, or a real part and a real part. So I can combine these because they are like terms. -2 plus 1 is -1. And then if I look at my my imaginary parts, I have 5i plus positive 7i. So 5 plus 7 is 12i. And that is all I can do with that one. So this is our answer here. For number 6, we are subtracting. And when I am subtracting two binomials or two polynomials, I think it's very important to distribute that minus sign through, like a -1, because you often will mess up the signs or forget to subtract. So minus the -1 turns to +1 or +1, and minus this positive 2i turns into a -2i. And then I will just rewrite the 4 plus 6i part. And again, I'm looking for my like terms. So I have the real part of 4 and the real part of 1. 4 plus 1 is 5. And then I have the imaginary part of positive 6i and the imaginary part of -2i. So 6 plus -2 is a positive 4i. So that is my answer there. When we're multiplying these, we're going to multiply them just like we do when we have two binomials, except for we need to make sure we remember to replace an I squared with the -1 that we talked about earlier. So I will start by distributing my 2. 2 times 9 is 18, and 2 times -3i is -6i. And then I have my positive 4i times 9, so that's a positive 36i. And my positive 4i times -3i. 4 times -3, that's -12. And I times I is I squared. And now I will combine any like terms that I have. So I have my 18 here. I have the -6i plus 36i. So that's a positive 30i. And then I bring down this -12, but I'm going to replace this I squared with my -1. So -12 times -1 is a positive 12. And now I can combine my like terms again because I have 18 plus 12. So 18 plus 12 is 30, and then plus 30i. So my solution or answer is another complex number. All right. So if I multiply this pair, I have 1 times 3 is 3. 1 times -6i is -6i. And then I have positive 4i times 3, which is 12i. and 4 times negative 6i, which is a negative 24i squared. So I'll bring down my 3. Negative 6i plus 12i is a positive 6i. Then I have minus 24 times the negative 1. So 3 plus 6i, that becomes a positive 24. And 3 plus 24 is 27. Okay, so we have complex conjugates, just like we have the radical conjugates. So A plus BI and A minus BI are those conjugates. So you remember, you're adding, it's the sum and the difference of those, the real and the imaginary numbers. And when you multiply these together, you end up with just a real number. So multiplying the conjugates equals a real number. And then just like we cannot have a radical in the denominator, we also cannot have a complex number in the denominator. So again, just like with the radicals, we can multiply by the complex conjugate to get rid of our imaginary number or complex number in the denominator. So if I have an I in the denominator, which is not allowed, I'm going to multiply by a positive I. You can multiply by a negative I, and we'll see what happens. So we will distribute. I times 2 is 2i. I times this positive 3i is 3i squared. And then I times I is I squared in the denominator. Okay, so now I have to replace my I squareds with that negative 1. So I have 2i plus 3 times negative 1, and this is all divided by negative 1. Had I chosen to multiply by a negative I here, my signs would have been switched, and I would have just had a positive 1 in the denominator, which would be a lot simpler. But I wanted to show you both ways, or how it works. So we have 2i. 3 times negative 1 is negative 3. And I still have this negative 1 below here. But if I divide everything by negative 1, this will now be a negative 2i and a positive 3. And I would accept this answer, but just so you know, typically we write the real part and then the imaginary part. So these are both the same answer. And this one is acceptable, but this is the preferred way to write the answer. So let's look at another one here. Here, I need to get my I out of the denominator so I can multiply by the reciprocal. I leave the 1 and change the imaginary part. And I multiply that in the numerator and the denominator. So distributing the 8 gives me 8 minus 16i. And now I have to multiply these two. So 1 times 1 is 1. 1 times negative 2i is negative 2i. 2i times 1 is 2i. And 2i times negative 2i. So that's 2 times negative 2 is negative 4. I times I is I squared. So when I combine like terms, I have a negative 2i and a positive 2i. So they are 0. So let me write my numerator. And then in my denominator, I have 1. And then I have this negative 4. And the I squared is negative 1. So I have to multiply those. All right. So my numerator is still, just this. Negative 4 times negative 1 is a positive 4 plus 1. So that's going to give me 5. I have 8, 16, and 5. They don't have anything in common, so I can't simplify or reduce. This is my solution. All right, and my last example. To get 1 minus I out of the denominator, I will multiply by 1 plus I. All right, so I have 2 times 1 is 2. 2 times I is 2I. I times 1 is 1I, and I times I is I squared. 1 times 1 is 1. 1 times I is I. Negative I times 1 is negative I. And negative I times I is negative I squared. So in the numerator, I have 2. And then the 2I plus I is 3I. And then the I squared is a negative 1. And in the denominator, I have the 1. Positive I plus negative I is 0. And then I'm minusing I squared is another negative 1. So make sure you use both signs there. So we simplify the numerator. I have 2 minus 1, which is 1 plus the 3I. And in the denominator, 1 plus 1 is 2. And once again, I have 1, 2, and 3, which cannot reduce. So that is my answer.